Alright, so this is variables and functions within RobotC. Variables and functions are basically how you're going to make any kind of complex program. Anything more advanced than just turning the motor on and off, you're going to need variables and functions. If you want your program to do anything intelligently, again, you're going to need variables and functions. So let's get started. A variable, like it says here, it's just a spot in memory that stores something. That can be any number of things depending on how you create the variable. Variables basically make your code more legible, and they make it much easier to change things. We'll go over that in a little bit. Like for example here, that's just a variable. We created an integer named cleared. It's equal to 0. Don't worry if this doesn't all make sense right now. We're going to go over it in greater detail in later slides. So when we create a variable, it's called a variable declaration. We declare the variable. Now there's two things that are absolutely necessary to create a variable, and that's we need to tell it what kind of variable it is, and we need to give it a name. The name should be descriptive. You don't want to make it too long because you're probably going to be typing it out multiple times. And when you're writing something that's multiple words, say for example if I wanted to say number of words, you want to use something that's called camel case, and that just means we capitalize instead of space. So for example it would be number, capital O in of, capital W in words, number of words. And that's just because you can't use a space in a variable name. You have to use just characters, and that just makes it more legible, more easy to read. It's not necessarily a requirement, but you should do it. Alright, so there's a bunch of different types of variables. In this class, we're only really going to be using 3 of them, and those are integer, floating point number, and Boolean. The shorthand for those, what you're going to actually type in the code, is int for integer, float for floating point, and bool for Boolean. An integer is just any number, a floating point is any number that involves decimal places, and a Boolean is just a true or false. Characters and strings, they are in RobotC, and you could use them, but they're not particularly useful just with what we're doing. So you should know what they are, you should be familiar with what they are, but you're not going to need to use them in this class. Alright, so when we create a variable, we've already gone over how to declare that variable, and that's, you can see that here. We have our declaration statement with what kind of variable it is, what name it is. Then immediately after that, you have to give it a value. A variable is not useful until you store something in it. If you try and access a variable without storing something in it, you're going to get gibberish. It's not going to make any sense. It's not going to be useful. So make sure you store something in there. And the most common way to do it is the most common way to initialize a variable is to just roll it all into one. This is all you need to type. This is equivalent to this. The declaration and initialization are usually just 1 line. You can do it in 2 lines for various reasons, but inside the scope of this class, you're probably not going to need to do that. This is the important part, using the value of a variable. So a variable can basically be used anywhere we would have a number. So for example, in this statement, we're setting a motor named left motor, and we're setting that to a value. This is -1, and this is, it's important to note, this is times. We use the asterisk as our multiplication operator. So -1 times whatever is stored in the speed value, or the speed variable, excuse me. If this is 127, we're going to run this motor at -127. If this is 3, we're going to run the motor at -3. We can put whatever we want in for speed, and it's going to treat this just like it was the number we put in. It's important to note that this has to be an integer or a floating point. If you put in a Boolean value, it's not going to behave how you want it to. You need to put in an integer. And of course, using the variable like that doesn't change the variable. The only way you can change the variable is by assigning it a value, just like how you initialized it. And also, it's important to note that it's going to run this line, and the compiler is going to run this line. It's going to move on. If I change speed later on, it'll only do anything with the motor if I run this line again. Otherwise, it's not going to do anything. All right, so assignment is how we change the value within a variable. Initialization is a special kind of assignment. That's the first assignment. Just like you can see here, you declare, initialize, assignment. Now it's important to note that when we say things equal other things and stuff like that in programming, it's very different than it would be in algebra. This isn't something with a solution. We take this part and we say this value on the left, or this variable on the left, is equal to the value on the right. That's what this single equal sign means. That's an assignment operator. We'll go into that a little bit. There are other uses for the equal sign that you want to watch out for, but a single equal sign always means an assignment. So yeah, it's very important that when you assign a value to a variable, the value you are assigning is on the right, the variable is on the left. If you try and write this, you're going to get a compiler error because it's not going to understand this. This side, the left side, needs to be the variable we're changing the value of, and the right side needs to be the value we are storing in it. As we can see here, you can use the variable that you're assigning to in the assignment for the variable. So every time we would run this line of code, it would half whatever was in here. So say if I have 50 in speed, and then I run this line of code, it'll divide 50 by 2 and set it into speed. So variables are extremely useful. You're really not going to encounter any code in the real world that doesn't use variables. It's what allows us to make programs that react intelligently to input and provide output that makes sense. So here's just 5 examples of variable use. We're going to go over each of them individually. All right, so if we wanted to loop something some number n times, we need variables. There really isn't a way to do this without writing the same code a bunch of times. You need use variables for this. So here's our code. We have our initialization and declaration of the variable here. And then we're using a while loop, and it's checking the value within our variable. And then every time we run this while loop, we are incrementing the count variable by 1. So it's important to note a couple of things about this. First off, it's going to count 0, 1, 2, 3, 4. Once it hits 5, it's not going to fulfill this condition anymore because 5 is not less than 5, so it'll break out of this loop. So it is going to run 5 times, but it's going to go 0, 1, 2, 3, 4. That's what it's going to do. It's also important to note that in this comment here where it says do something, we could put anything we wanted, and it would run that 5 times as long as we didn't mess with the count variable. It's also, third thing that's important to note, there's a lot of different ways to increment a variable. It's something you're going to be doing very often, so it's very important to have multiple ways of doing it. This is the most wordy way of doing it. There's a couple of easier ways. If you actually do count plus equals a number, like for example if it said count plus equals 1, it would simply add 1 into count. If I did count plus equals 5, it would add 5 each time we looped through here. Also, if you're just incrementing by 1, that's common enough that there's an even shorter way to do it, and you just say count plus plus, and that increments it by 1. So yes, make sure that you are familiar with all the different ways of incrementing, and you're familiar with how this counts up. So another application, we want to count how many times something happens. So we're basically using a variable as memory. We're using a variable to store how many times we push a button. So what we're saying here is we create, again, assign and initialize some variable that's the number of presses. While this limit switch is not pushed, and again, this is our checking, this is our Boolean check Remember, this is not the same as an assignment. That's very, very, very important. That's a super common mistake. This says, is this equal to this? This says, this is equal to this. That's a very important distinction. I'm probably going to talk about it a couple more times in this video. All right, so anyway, what this program does is while this is true, if we push the button, it's going to increment the variable n presses. So what this is doing is it's just when it sees that it pushes down, it's going to do this, and then it's going to wait until it's released. And then we have a little wait statement. That's called debouncing. That's a very, very important part of programming anything with a button, because when we actually push a button, we're not going straight from 0 to 1. We actually flicker back and forth a little bit. So if you don't want those flickers to register as a bunch of button presses, you need to wait a little bit to make sure that it's a real button press. Otherwise, your code's going to go wild. You're going to get like 1 million button pushes when you only pressed it once. Another application, remembering whether anything happened. We're just waiting for something to happen, and when something happens, we say, okay, it happened. This is called a flag. A flag is anything where it kind of watches something, and then when something happens, we throw the flag. We say, okay, it happened. And it stays that way until we clear it out. So here's our program. Notice we're using a Boolean variable here, because a Boolean variable is only true or false, which you're going to use a lot in computers, computer science, any programming at all. You're going to use Booleans a lot. So this is going to be our flag. So we clear out our timer, turn off our flag, clear our flag, and we're going to start a timer. And within this 5 seconds, this is waiting till this reaches 5 seconds. We're going to just run this a bunch of times. We're just going to check if over and over and over and over and over and over and over. Is the button pushed? Is it pushed? Nope. Okay. Is it pushed? Nope. Okay. And then when the button finally is pushed, we're going to say, okay, the flag is true. In this while loop, we're never clearing touched. We're never changing touched from anything but true. That's just so that by the end of this while loop, if the button was touched at all, it's going to still be true. This actually has a lot of uses, and there's a couple of little tweaks you can make to totally change how it works. For example, if I put touched equals true, or sorry, excuse me, touched equals false in this condition, then it would just run this piece of code infinitely until the button's pushed, and then it would move forward. That's very similar to your until bumped function that you use with the Project Lead the Way natural language. That's basically how it works. So it's important to understand that as well. So another application, remembering a maximum. This is very handy if you've ever used, say, a scale or a digital multimeter or a thermometer. A lot of them have some option to remember a maximum value. That's very useful information to have. So what we do here is we're just doing the same thing as before, except instead of a Boolean, we actually have an integer. So this is storing a number. So what we're doing is we're going to go through this while loop a bunch of times, and we're going to each time check to see if the sensor value of this knob is greater than the most. So if it ever gets greater, it's going to assign that greater value into most. If it's less, it's not going to run this. So only when it surpasses most will it write the new variable into most. This is kind of cool just because it's sort of working all on its own. It checks against most, and then if it's higher, it applies it to most, and that increases this value of most, and now it's only going to trigger if it's even higher. And like it says, this is very similar to the previous code, except this is using an integer instead of a Boolean value. This should be number 5. And this is a very, very, very useful application when we're programming. This is something you might want to remove when you're finished with your code, but in this class I would actually prefer that you keep it in. It shows that you are testing things and you're doing good work. The idea behind this is that we're setting a variable to some new value on each step of the program. So, for example, in this one, we set b equal to 1 at the start, set b equal to 2, if the sensor value surpasses or is under a value, and then we increment another variable a every time we go through this while loop. And when we're finished with the while loop, we go set b to 3, and when we're finished with this block of code, we set b to 4. So this can be really useful in checking errors. For example, if you look in your code and it's just hanging on 1, for some reason it's never going through this if statement, which would be odd. That would be something you would want to check out. Maybe you commented something out, maybe you accidentally wrote some bit of code that causes it to just skip all of this. Like, those are all possibilities. If it goes to b equals 2, then you know, okay, it detected the sensor value of the light was less than 500. A is handy because you can see how many times it's incremented. If A never changes, even though this is true, then there's clearly a problem somewhere, like something's wrong with this while loop. B equals 3 when this while loop's finished. If B equals 3 at the end of the program, you know, okay, it went through the while loop and it finished. And then B equals 4, it runs that after this entire block of code. So if B equals 4, you know it went through all of this, or at least it leapfrogged over here, maybe. Like, a lot of different things can happen, but by having these variables in place, you know where in the code you are. Of course, to do this, you have to enable the debug window. That's global variables, and you'd have to look at that tab to see where those are. Otherwise, it's useless information if you can't access it. So that leads us into scope. Now, this is a very important area to know about variables. Variables have a certain scope, and a scope is just the area over which they can be accessed. A global variable can be accessed from anywhere, and a local variable can only be accessed from within the task or function that it's used in. We are going to go over functions in a little bit, so don't worry if that's not a familiar term. A good analogy for this would be, say, Google Drive versus the files on your desktop. Files on your desktop would be local. You can only get to them from that computer. If you're halfway across the world on your laptop, you're not going to be able to access the files on your home computer. They're separate. They're not connected. A global variable would be like putting a file on Google Drive. Anywhere you can go, any computer you access, you'll have access to that. Just like in any function or task you go to, you're going to have access to the global variables. Alright, so this is how we create a local variable. This is what you're used to already. This is what you've been doing. See this integer rotations that we're creating. This is the local to task main. If I have another function, if I have another task, I'm not going to be able to access rotations because it's local to task main. It will only be able to be adjusted, changed, used within this task. Now, if we want to create a global variable, and you're going to want to do this because it's very handy for debugging. You don't want to do it too much because you don't want all your variables to be global, or you're just wasting space and resources. So don't do that. But if you have something you want to look at on the debugger window, you're going to want to make it global. So you make something global by declaring it outside of any tasks or functions. So this is our function, and this is our task. We're creating rotations outside of there. So then if you look in this, actually, whenever we run forward back, it's going to set rotations to 4. In the beginning of task main, it's going to set rotations to 2. So if we were to run this code, you would start the motor at half speed until 2 rotations had passed, stop the motor, run our function, which would then set rotations to 4, start the motor again at half speed, run 4 rotations, stop, and then run 4 rotations backwards and stop. This same variable, even though it's in 2 separate functions or tasks, it can still be accessed by both. So that leads us to functions. A function is just basically there to make your life easier. You use a function for something that a block of code that you're going to use a lot. So for example, if I want to blink an LED, and I use that every step of the way, like whenever a motor moves, I blink an LED. If I want to, that's my debug, that's how I know things are running, I'm blinking that LED. I might want to make that a function call, so I have to write out less code. Here's a sample program that's using a function. There's three main points that I want you to see. First is this. This is our function prototype or declaration. This is us calling the function, and this is the actual definition of the function. So we'll go through this piece by piece. But basically, the declaration of the function, or a prototype, is just telling the compiler that the function exists. It's just saying, don't freak out if you see me say LED control, because I made it. It exists. It's there. Note that you don't actually need to do this. You can actually declare, like in here, if you see like this void LED control, that's the definition. They define this down here. I can define this up here if I wanted to. I can define it above task main. As long as it's not inside of task main, I can do it wherever I want. If you were to declare that above task main, you wouldn't need the prototype. It wouldn't need it. You only need this if you're doing this, if you're creating your functions and defining your functions after task main. This is just saying, don't freak out when I write that code in task main. It exists. Another thing I should add, if you have a lot of functions and you write prototypes for all of them, you can just add a comment for each line saying just a little tiny line on what that function does. And it's super useful if you come back to your program later, you look at it, you go, what are all these functions doing? You have a quick little list right at the top of the program that tells you exactly what they're doing. It's very handy. All right, so this is our function definition. This is basically just the code that it's going to run. So what this says is whenever I say LED control, whenever I call this function, it's going to do all of this. So it's going to check the sensor value, it's going to turn the LED on or it's not. It's going to do everything within these two brackets whenever I call this. And remember, with local and global variables, if I have a local variable in here, it's going to initialize and use that variable only one run through of this function. So then finally, here's the function call. This is how we use it. We just plug this in, LED control, parentheses. That's just how it's used. But real quick, I wanted to go over two things that are really, really, really important for functions that actually don't actually have slides for them, but that is arguments and returns. So, all right, so an argument is something that we give a function that it can use. You know how you have local and global scope. Function arguments and function returns, for that matter, are kind of your way around that. So say we had some variable inside this LED control function, and we wanted the LED to only turn on if, or actually no, here's another one. Here's a good one. Say we want the LED to turn on if we say LED control true. We want this LED to turn on, and otherwise we want it to turn off. What we would do is inside LED control, inside these parentheses, I could declare a variable. I could say bool on, and then a semicolon. And that would create an argument. And then inside of this function, I would then have the ability to say on as a variable, as the one I declared inside these parentheses. And that variable would work just as a normal variable. But then, let's go over to function call. When I call the function, inside here, inside these parentheses, I would say true or false. I would give it a Boolean value. And then that would assign that Boolean value to the variable that I had put in the argument. This is a little bit more of an advanced concept, and you're not necessarily going to need it in this class, but it is something important to know, and it'll probably come in handy in some of your later projects. Likewise, like those, we have we have arguments and then we have returns. Now you might have noticed in the definition of this function, it says void. Void is a special type of function. Now this is set up just like a variable, right? Except void is a special type that means you don't return anything. If I were to replace this void with, say, an int, then that meant this function would return an integer. And the way I would do that is at the bottom of the function, I would add an extra little line that says return and then a variable name or a value. For example, if I wanted LED control to return a 5, I would just say int LED control, and I would say return 5 semicolon, just to end the line, as you normally do. Now what that would do is if I were to call the function, and I were to say I have a variable in here that's named test, int test, so I put that right here, but int test. If I say test equals LED control, then it's going to take that 5 that I returned and it's going to put it into that test. Now this is really, really powerful because say I want to have a function that does some math. Then I could have 2 arguments. Say one is, let's say we're doing exponents, and one's the base and one is the exponent. Then I could do that math using a function. And I could have the 2 inputs as arguments, and I could have the answer as a return. I could return that answer in the form of like putting return a variable. That's just a little bit on how those work. It's important to know about, but it's not something you're necessarily going to need. That being said, I would recommend brushing up on it a little bit, checking online, checking on YouTube, checking everywhere, because you should understand that to be the most effective program you can be. That is everything. Thank you for listening, and hope you enjoyed the video.